Right. See, chemical properties are very important. I hope you learnt all preparation methods. Sunday I'll conduct the test on alkyl halides and alcohols. So keep on preparation, everybody. Okay. Chemical properties. See, in the first chapter we have seen nucleophilic substitution reaction, and even electrophilic addition also. Electrophilic addition also means you know these terms: nucleophile, electrophile. Okay, two types of reagents are there: nucleophiles and electrophiles. These are the reagents actually. See the specialty of alcohol. Alcohol can act as a nucleophile, and alcohol can act as an electrophile also. Okay, that is the importance of alcohol. Alcohol is having dual character. Alcohol can act as electrophile, alcohol can act as a nucleophile. I'll tell you when alcohol acts as electrophile, when alcohol acts as a nucleophile. This is according to NCERT. According to NCERT. In NCERT it is given. Okay. Chemical properties. Reactions due to I am taking one alcohol CH3OH and I am breaking carbon oxygen bond. Carbon and oxygen bond. This is one category. And another one CH3OH reactions due to OH bond breakage. Alcohols participate in the chemical reaction in two ways. Okay, first way or first method is involvement of carbon oxygen bond. Second method is involvement of oxygen and hydrogen bond. Reactions due to OH bond cleavage. Reactions due to CO bond cleavage. Clear? So when CO bond cleavage is involved, then alcohol acts as a electrophile. The reactions in which OH bond is involved, then alcohol acts as a nucleophile. This is very important according to NCERT. See here which bond is involving? Carbon oxygen bond is involving, right? Now in this case alcohol acts as electrophile. See when CO bond cleavage takes place, when CO bond cleavage takes place, then alcohol acts as electrophile. When OH bond cleavage takes place, then alcohol acts as nucleophile. We have two types of reactions. Right. Now let us start this one. Reactions due to CO bond breakage. Okay. So remember, overallly, alcohol can act as electrophile and alcohol can act as nucleophile. When alcohol acts as electrophile, when CO bond cleavage takes place. When alcohol acts as nucleophile, when OH bond cleavage takes place. Let us start first reactions due to CO bond cleavage. CO bond cleavage or breakage. Completed? Shall I clear? All of you. Reactions due to CO bond breakage. This reaction, you know already in alkyl halides, this reaction came. All of you look at this, you know very well about this. Anybody, can you tell me? SOCl2. Alcohol when treated with SOCl2, what is the role of SOCl2? Few students didn't listen alkyl halides. Now listen now. When alcohol is treated with SOCl2, thionyl chloride, what is its name? Thionyl chloride. Total OH group will be removed and Cl will be added. RCl, and byproducts are HCl and SO2. So you have to identify the reaction. What happens when alcohol is added with SOCl2? Remember, OH group will be removed and Cl will be added. Clear? OH and Cl will attach. Next, SOCl2 pyridine. Here also same, but what is the difference? Here we will get inversion product. Inversion product formation takes place. What is inversion? What is retention? I will give the example. I given already example in the alkyl halides chapter. What is the meaning of inversion? What is the meaning of retention? Okay. Already you know all these reactions in alkyl halides chapter. You studied under preparation of alkyl halides. Yes or no? Tell me. You prepared under preparation methods of alkyl halides. Now anybody, can you tell me what is the product when alcohol is treated with PCl5? Alkyl halide is formed. Next, very good, POCl3 plus HCl. Byproducts are important. Here you have to learn the byproducts. See, whatever it may be the reagent, SOCl2 pyridine, PCl5, what you have to do? Remove OH and attach halogen. That is the main. Next, with PCl3, RCl, tell me, and H3PO3. Here, and I given about Lucas test briefly in the alkyl halides chapter. Okay, Lucas test. Once go through the Lucas test also. I said in the first chapter only. In the next chapter this will come. I will skip the Lucas test. Once you can see or watch the Lucas test. Once again I will revise. No need to worry. Okay. Reactions due to CO bond breakage. Sometimes you will get a question on the type of cleavage also. When alcohol is treated with SOCl2, alkyl halide is formed. What type of cleavage is involved? Carbon-oxygen bond cleavage is involved. Right? Let us take some examples and let us understand what is inversion product, what is retention product with SOCl2. With PBr3 also retention product or inversion product. With PBr3, inversion, PBr3. Let us start examples. Shall we go to next page, all of you? Right. SOCl2. Don't do any research. When you observe alcohol and SOCl2, simply remove OH and attach Cl there. CH3, CH2, Cl. Byproducts are SO2 and HCl. This is the best method to prepare alkyl halide. Why? Here you are getting alkyl halide or not? Why this is the best method to get alkyl halide from alcohols? Why this is best method? Because byproducts are because by gases. Byproducts are the gases. These reactions were covered in alkyl halides chapter. These are not new to you. You are learning second time. I said already. First chapter reactions will come in the second chapter. First, second chapter reactions will come in the third chapter. Repetition there. Next, let us understand inversion and retention with one example. Here alcohol is present above the plane, thick line OH, and this is one methyl group, SOCl2, plain SOCl2 and pyridine, SOCl2 and pyridine. So what is the main basic mechanism, basic reaction? In place of OHCl will come. When we add SOCl to alcohol, in place of OHCl will come. Now see the arrangement. OH is above the plane. Thick line means above the plane. Here also Cl is above the plane only. So same, is there any change in the configuration? No. In the reactant, OH is above the plane. In the product, Cl also above the plane. This is called retention. No change. Retention product. No change in the configuration. Retention. For example, if here configuration is R, here also configuration is S. You know RS configurations in the stereochemistry first year. Okay. This is retention product, means configuration is same at chiral center. This is chiral center, so configuration will be same at chiral center. With SOCl2 and pyridine, observe here. This is methyl group. See here. Dashed line means below the plane. In the reactant, OH is above the plane. In the product, OH is below the plane. Opposite. Okay, opposite means back side to the board. Above and opposite. So this is inversion. See, configuration is changed at this carbon. At this carbon, configuration is changed. Here I have to write Cl, sorry. No one is saying. Clear? That is the meaning of inversion and retention. Inversion configuration. So when pyridine is given to you, write inversion product. Inversion product means if OH is present above the plane, put Cl below the plane. If OH is present below the plane, put here above the plane. Means opposite. If thick line is present, put dot line. If dot line is present, put thick line. Inversion, opposite. But with retention, same. Thick line, dash line, same. No change. Okay, all of you. Shall I clear this? See, OH, what is the orientation of OH? OH is present above the plane or below the plane? Above the plane. Here chlorine is present above the plane or below the plane? Above the plane. So same configuration. Retention means as it is. At this carbon, configuration is not changing. At this carbon, OH is above. At this carbon also OH is above. In the reactant and the product, this carbon configuration is not changing. That is called as retention. But when you take pyridine solvent, in the presence of pyridine, see this carbon configuration is changing. Cl is below the plane. Actually, OH is above. Instead of above, Cl is present opposite, below the plane, opposite. Okay. If configuration is changed, arrangement of atom is changed, that is called as inversion. Atom arrangement is changed or not? At this carbon, Cl is below the plane, below the ring, Actually, this is a 6-membered ring. Let us consider this as a 6-membered ring. In the product, for example, consider this carbon. In the product, OH is above. In the reactant, Cl is below, like this. That is called inversion. Instead of that, in the reactant, if OH is above, in the product, Cl is above. Both are same. Above and here also above. That is retention. Other case, in the reactant, OH is above. In the product, Cl is below. Both are opposite. That is called as inversion. Inversion in the sense of change in the configuration. In stereochemistry, you have configuration, RS nomenclature, R and S configurations. If it is R, here you will get S. In pyridine solvent, without pyridine, R, here also R. If S is present, here also S will present. Clear? All of you. See, just you change the configuration only. If you observe thick line, put dash line. Simple. When pyridine solvent is given to you. Any doubt in this? Meenakshi, followed or not? Can you try this, all of you? Try this, write the products. I'm giving numbering 1, 2, 3, 4. You tell me in the product. At second carbon, what is the arrangement of Cl? Above the plane or below the plane? In first, you tell me Cl will be represented with a dash line or thick line. Cl will be dash line. Dash means same like this. Thick line, wedge line, opposite. This is called as inversion. When you observe pyridine, take opposite configuration Cl. If your dash is present, take thick. Complete opposite when pyridine is present. Plain SOCl2 as it is. Dash, here also dash. A retention with SOCl2 retention. Same, no change. When pyridine is not present, no change. What is present here, you have to write the same configuration. Clear now, everyone? Got it, all of you? Next property, next keep heading. Shall I go to next property? Dehydration of alcohol. Dehydration of alcohol. This is also reaction due to CO bond only. Dehydration involves CO bond cleavage. Reaction due to CO bond cleavage or breakage. Very important property. First property is very easy only with SOCl2. Okay, remove OH and attach Cl. Very simple example that is. But I given some additional information, inversion and retention concepts, right? But basically, when you observe alcohol along with SOCl2, remove OH and put Cl. Okay, like this. There is no difficulty in the last example. What you have to do when you observe SOCl2 and ROH, alcohol, just you remove OH and put Cl over. Okay, very simple chemical property. But second one is lengthy, in a time taking and most important. Dehydration of alcohol. See, removing water from the alcohol is called as dehydration. Dehydration means removal of water. Removal of water. Okay, it is a type of reaction in which CO bond cleavage takes place. First of all, what is dehydration? Removal of water. Removal of H2O, removal of water is called as dehydration. Removal of water is called dehydration. You should know the reagents list. Everyone should by heart the reagents list. Reagents to remove water from the alcohols. First one is concentrated H2SO4, concentrated sulfuric acid, the best reagent used for the dehydration. Concentrated sulfuric acid. Second reagent, concentrated H3PO4, orthophosphoric acid. Third reagent, P2O5, phosphorus pentoxide, heating. Fourth reagent, Al2O3, followed by heating. These are important dehydrating agents. These are used to remove water molecule from alcohols. You have to by heart. Don't learn one reagent. Learn all the reagent. I am already filtered unimportant reagents. Okay, you don't filter. If 4 are given, learn 4 reagents. Without having idea about the reagent role, you cannot understand the reaction. Clear? Concentrated sulfuric acid means everyone should say, sir, this is a dehydrating agent. It removes water molecule. Similarly, orthophosphoric acid, H3PO4, orthophosphoric acid, that is also dehydrating agent. P2O5 also dehydrating agent. Al2O3 also dehydrating agent. Okay, right. I'll give you one simple example, right? Then we will go with the mechanisms, rearrangement, everything. This is a vast topic, okay? Very lengthy topic and most important also. Let us see some simple example. One simple example. Have you copied this? All of you. I am taking ethanol, CH3CH2OH, ethanol or ethyl alcohol. When it is treated with concentrated sulfuric acid, concentrated H2SO4, see, water will be eliminated, minus H2O, and we will get a alkene. I'll give you shortcut mechanism, but here we have to discuss the original mechanism also. I'll give you shortcut mechanism as well as original also. See the mechanism, this is shortcut. We'll discuss original mechanism also. See, first shortcut. CH3 can be written as CH2H. Okay. Next, CH2OH. I am writing this OH down. OH down. CH2OH can be written like this. Is there anything wrong if I draw like this? Nothing is wrong. Okay. Concentrated sulfuric acid is added. What happens? Look at this. Water will be eliminated. Look at this. Minus H2O. Minus H2O. Water will be eliminated. Okay, remove water. Remember one important point. When you remove two atoms or groups from the adjacent carbons, you are removing these two together as a water molecule. You have to put one bond, double bond. Okay, when you remove two atoms or groups from the adjacent carbons, you have to put double bond to complete the valency. So alkene is the product. Water will be eliminated, OH and H2O. So when you remove two atoms or groups from the adjacent carbons, put one bond, extra bond in the middle. Okay, don't forget this. Shortcut mechanism. This is alcohol, ethyl alcohol. When it is treated with sulfuric acid, it loses water molecule to produce alkene. This reaction came in alkenes chapter in first year. This is also not new to you. Okay. ethene is produced. Ethene or ethylene. Alkenes are the products. What are the dehydration products of alcohols? Alkenes. Dehydration products of alcohol or alkenes. Alkenes are produced. Right. Now let us see some important examples and mechanisms. Mechanism is most important. Original mechanism. This is just for idea how water will be eliminated. Clear? But everyone should know about original mechanism. Clear? Right. Before that, I am giving one important example. Everyone should by heart that. Very, very important. What is its name? Ethanol. Ethanol. Concentrated sulfuric acid. What is concentrated sulfuric acid? What is its role, girls? What is the role of concentrated sulfuric acid? Dehydrating agent. Concentrated sulfuric acid. What is the difference between these two? What is the difference between these two? See it? Temperature difference. Al2O3 350 degrees centigrade. Al2O3 250 degrees centigrade. Most important temperature conditions. Based on the temperature, product will change. Product will change. Okay, this is a very important example with the temperatures. See, when we treat alcohol, ethanol, especially ethyl alcohol with sulfuric acid at 170 degrees centigrade, it loses water molecule to produce ethene. Before that, I given one example. CH2 double bond CH2. Right? At 170 degrees centigrade, at high temperature, elimination takes place. Water will be eliminated. Water will be eliminated. When we decrease the temperature, instead of elimination, substitution takes place to produce ether. Very, very, very important. I'll tell you shortcut mechanism to remember this. Wait for some time, I'll give you. Ether formation takes place. Ethyl and ethyl, diethyl ether, diethyl ether at which temperature? 140 degrees centigrade. At 140 degrees centigrade. At 170, alkene is formed by the elimination of water, loss of water. Okay. Next, similarly, when ethanol is treated with Al2O3, you know Al2O3 also dehydrating agent. I given Al2O3 also dehydrating agent. At 350 degrees centigrade, like here how ethene is formed, here also ethene is produced. Right? Here same substitution takes place to produce ether. Most important example. There is no logic in this, by hearting only, remembering, preparing. Okay. But for this, I'll give you one shortcut mechanism. You know about this removal of water only. No? This is before that I given already. Okay, H and OH, removal of H and OH. The ether formation. See this. If you want, you can write. Otherwise, remember. See, when ethanol is treated with sulfuric acid at 140, what will happen? This shortcut mechanism, not original mechanism. To remember the product, I am giving this. Actually, this should not given, but there is no other way. Take 2 molecules of ethanol and remove water molecule. OH and H. What will remain? CH3, CH2O, CH3, CH2. Join these two. Join these two. Remove water. OH and H. Remove water. Okay. And remaining part CH3, CH2O, CH3, CH. Join these two. So one oxygen is present in the middle. CH3, CH2O, CH2, CH3. It's just for to write the product only. Clear? This is not original mechanism. Okay, this is a shortcut actually. This is a different mechanism, substitution mechanism. Takes place by substitution here. Product takes place by substitution. Now, can you tell me what is the hybridization of carbon here? Anybody? What is the hybridization of carbon here? Carbon hybridization. What is the hybridization of carbon here? Carbon. Sorry. sp3. sp3. sp3 means tetrahedral. Tetrahedral means planar or non-planar. Planar or non-planar. This non-planar. This carbon hybridization is sp3. This is a non-planar molecule. Non-planar molecule. Non-planar molecule. Here hybridization is sp2. sp2. This is additional point to you. Additional points I am giving to you. Hybridization is sp2. sp2 means geometry trigonal planar. So this is a planar molecule. Sometimes they will ask about the structures of the products. Okay, when ethanol is treated with sulfuric acid at 170 degrees centigrade, you will get a planar molecule because ethene is a planar. Why hybridization is sp2? When it is treated with sulfuric acid at 140, you will get a non-planar molecule because the diethyl ether in this carbon hybridization is sp3, tetrahedral, non-planar molecule. Here also same, planar and non-planar. Additional information. But basically you have to remember the temperature conditions and the products. Clear everybody? Mechanism of dehydration. Mechanism of dehydration. Let us take one simple example. Let us take ethanol, ethyl alcohol, CH3, concentrated sulfuric acid. Concentrated sulfuric acid is the dehydrating agent. Okay. Alkene is formed by the elimination of water molecule, by the loss of water molecule. See the mechanism. Step 1, step 2, step 3. Step 1. Which of the following is not the step involved in the dehydration of alcohol? Sometimes you will get the questions on the concept also. Concept also. Clear? Which step is not involved in the dehydration of alcohol? That type of questions also you will get. Okay? Right. What is step 1? Protonation. Protonation of what? Protonation of alcohol. Protonation of alcohol. Protonation means addition of proton, H plus 2 alcohol. H plus 2 alcohol. Okay. I am taking sulfuric acid and dissociating it to get proton. H2SO4 dissociates into H plus and HSO4 minus. HSO4 minus. Right. What is step 1? Protonation of alcohol. I am taking this alcohol CH3, CH2OH. You tell me oxygen contains how many lone pair of electrons? Oxygen is having how many lone pairs of electrons? 2 lone pairs of electrons. Proton released by sulfuric acid will be added to oxygen. H plus means electron deficient, right? H plus means electron deficient. Oxygen is having more electrons on it. Oxygen is carrying extra electrons. So oxygen donates its pair of electrons, one pair of electrons to H plus, proton. This step is protonation. We are adding proton. We are adding proton. This is called as protonation. Protonation, adding proton to alcohol. Alcohol is called as protonation, right? CH3, CH2, OH2, OH2. Already one H is present, another hydrogen is coming, so OH2. And very, very important point, I am writing positive charge on the oxygen atom. Why I am writing positive charge on the oxygen atom? Why I am writing positive charge on the oxygen atom? Anybody? Yes, yes, oxygen is giving its pair of electrons, means oxygen is losing its electrons, donating its electrons to proton. That's why it will get positive charge. Very, very important. Clear? Oxygen with a positive, because it is giving its pair of electrons to proton. Right? So first step in the dehydration of alcohol, protonation of alcohol. Clear? Step 1 is okay for everybody? Any doubt? Adiba, Aisha, Mazia, are you following? Mazia. Meenakshi, follow Tunava. Meenakshi. Srujan Nabu. Okay, na Srujan? Right. Next, step 2. Step 2. Loss of water or formation of carbocation. Loss of water or formation of carbocation. This is rate determining step. This is slow step or rate determining step. In SN1 I given about the slow step or rate determining step. Loss of water, elimination of water or formation of carbocation. In the last step we got one intermediate. What is that? CH3, CH2, OH2 positive. I am taking this as it easily. CH3, CH2, OH2 positive. Okay. Now you tell me, oxygen with a positive charge is stable or unstable? Oxygen with a positive is stable or unstable? More electronegative atom with the positive charge is unstable. You see, fluorine, oxygen, these are more electronegative atoms, even nitrogen also. If they have positive charge, they will become unstable. So they try to remove the positive charge over them. Look at this. In this bond, two electrons are present. Clear? But here oxygen is having positive charge. It is highly unstable. So what oxygen will do? Oxygen takes these two bond pair of electrons like this, along with it, and eliminated as water. See, oxygen is having positive. That's why oxygen takes its own electron, this dot, and this pink dot represents electron of carbon. Oxygen takes its own electron and electron of carbon also. Pink electron belongs to carbon, yellow electron belongs to oxygen, but oxygen will take its own electron and electron of carbon also to nullify the positive charge, to balance the positive charge. Okay. to form this carbocation, CH2 positive. Why this carbon is getting positive charge? Because carbon is losing its electron. The pink dot belongs to carbon. That electron is going. Okay, plus H2O. Got it, all of you? Is this step clear for everybody? Adiba, what about you? Next. Sorry. Come again, someone or ask. Oxygen with positive is unstable, right? In this bond, how many electrons are present? 2 electrons are present. Yellow electron and pink electron. Pink electron belongs to carbon. Yellow electron belongs to oxygen. Oxygen takes its own electron and electron of carbon also. Why it is taking electron of carbon also? Because to nullify this positive charge. Here one positive charge is there on the oxygen. To nullify, to neutralize that, nullify that positive, it is taking its electron as well as electron of carbon also. One extra electron it is taking because it is having positive. To neutralize that positive, it needs some extra electron or more electrons. Clear? This pink dot is electron of carbon. See, yellow dot is electron of oxygen. Pink dot is electron of carbon. Both are taken by oxygen atom. See this arrow. This arrow is including 2. Like this. And carbon is getting positive. Why? Because it is losing its electron. Next, step 3. From this carbocation, proton capture takes place. Step 3, capture of proton by the base. Capture of proton, H plus. Capture of proton by the base. Take this as easily. But one small change, the CH3 can be written as CH2H. Take this as easily, but instead of writing CH3, write it as CH2 and H. HSO4 minus. This base capture this proton. Look at this. This hydrogen without bond pair of electrons moves towards HSO4 minus. At that time, this bond will move towards this side. Because hydrogen is leaving its electron here only and going as H positive. Without taking any electron, it is moving. That's why I am writing positive. It is leaving its electron there only. So in between these two, double bond will come. CH2 double bond CH2. Why positive charge disappears here? Here I didn't write any positive charge. Why? Because bond is coming, right? Bond nothing but electron only. No? Electrons are coming here positive. Here electrons are coming towards this. Electron means negative charge. Positive charge and electrons are coming. Clear? So 3 steps are involved. Protonation, loss of water and capture of proton by the base. Got it? All of you. Any doubt in this? You have to do practice. Without seeing. Follow every step, each and every step. Clear? Will you do practice, all of you? Okay, today only, complete today only, don't keep any pending. Right, we'll continue tomorrow. So I am giving the time to you, don't keep pending. I can take another extend the class one more half an hour also, but to practice, okay, that is better. First try this, then we will go with another difficult examples. If I teach that difficult example, then you may feel some difficulty. That's why practice this simple example, mechanism of ethanol dehydration. Okay.